All right, here's the continuation of section 6.3 where we're factoring trinomials with a leading coefficient that's not a 1. And let's get a couple more jokes in there because these are fun. So, parallel lines have so much in common. That's a shame they'll never meet. That's a good one in light of our chapter 3 test. I enjoyed that. All right, how do you find Will Smith in the snow? Will Smith. You'll look for the Fresh Prince. That's a good one because, you know, Fresh Prince of Bel-Air. Oh, he was good in that. Really good in that. Okay, and let's try another one. I tried to catch fog yesterday. Missed. And the last one. An invisible man marries an invisible woman. Their kids were nothing to look at either. Oh my gosh. All right, that's enough of that. So, we're going to, again, factor trinomials with the leading coefficient that's not a 1, but we're going to look at some extra examples of this where we have to do some common monomial factoring before we get started. So let's take a look at an 80z to the third plus an 80z squared minus a 60z. Now remember, I taught you guys that you always look first to see if there's something common that you can divide out before you do anything else. If you look at these coefficients of 80, 80, and 60, I can divide a 20 out of each one of them. I can also divide a z out of every single term. And I'm going to write down in a parentheses what's left when I do that common monomial factoring. When I take the 80 and divide it by 20, I get a 4. Z to the third divided by z is a z squared. Here, 80 divided by 20 is again a 4. Z squared divided by z is z to the first, and a negative 60 divided by z is going to be a negative 3. The z's cancel out completely. So this is what I'm left with. Now, you should always look within this parentheses and ask yourself, can I divide this any further? Can I factor this anymore? And sure enough, with this one, I might be able to. Now, there's nothing common that I can divide out, because if I could, I would have done it from the beginning. So what I'm going to do now is try to see, can I set up that double parentheses? If so, it's possible that it might work by guess and check, but it might work by one of the other methods. Now, if I do guess and check, this tells me my signs will be different. And I'm going to split this 3 up into the back slots. Well, there's only one way to split up a 3. It says a 3 and a 1. This front slot will split up as either a 4z and a 1z or a 2z and a 2z. And I just have to take a stab at it and see what happens. If it doesn't work, switch it up. So I'll try the 4z and the 1z. Out here I get a negative 4z. And here I get a positive 3z. Those combine to be a negative 1z. That's definitely not what I want. And it's not even right number, wrong sign. So switching the signs is not going to help. So I need to switch up the numbers here. And let's call this the 4z minus 1, and let's call this the 1z plus 3. Now on the outside I get a negative z, and on the inside I get a 12z. Those combine to be a positive 11z, once again not even right number, wrong sign. So let's dump the 4 and the 1, let's pick up the 2z and the 2z and see how that helps. Out here I get a negative 2z, and here I get a positive 6z. Those combine to be, the positive 4z. So this is the factored form. Notice that I have to include what I divided out in the front and the beginning, because without it, if I only FOIL this, that'll only take me to here. I have to get all the way back to the beginning. So as I stated before in a previous video, this needs to stay in there, that 20z, so that once I get here, I multiply the 20z through. That gets me right back to the beginning, so I know that it's right. So this is what happens whenever you can factor out a common monomial, and then you can go from there. But notice that what I utilized here was that method of guess and check. I can still utilize that method of factoring by grouping. It's just if I use factoring by grouping, I only want to use it on that back parentheses. I certainly don't want to use it on this 20z that's out front. So if I do factoring by grouping within this, I will do the same thing that I did before. I just need to be sure that when I write my answer down in the beginning, I don't lose that 20z that I started with. So I'll take this 4 and I'll multiply it to the 3 to get a 12. That tells me I want two numbers that will multiply to be 12. These two numbers are going to subtract to be the 4 that's in the middle. Again, subtract because I know in the end I want different signs because this is a minus that's in the back. So the two numbers that will multiply for 12 and subtract to be 4 are going to be a 6 and a 2. So this splits up as a 6z and a minus 2z. And now what I'm going to do is I'm going to group up the first two terms and group up the back two terms. Here I'm going to divide out what's common. That's going to be a 2z. Write down in a parentheses what's left. That's going to be a 2z minus 3. And then here, notice that all I have to do is factor out the negative 1, leaving me with a 2z. Oh, I apologize. This should be a positive 6z. My deepest apologies here. So that this becomes a positive 3z, positive 3, and a positive 3 here. Now, like we said before, I've got a common binomial within each of the two boxes. So I'm going to take that common 2z plus 3 out, write down in parentheses what's left. I'm left with a 2z minus 1. And so that's going to be my answer. But remember, this will only get me back to here. This is my original problem. So I was a little trigger happy there when I circled it because I need to retain that 20z. Because now when I FOIL these and get back to here and I multiply the 20z through there, that will get me all the way back to the beginning. And notice that this is the very same thing that I've got right there. So the same thing that can happen with that box method. And with the box, it just simply takes what's here in that parentheses and finishes it off. So that 4 times 3 will give me the 12 again. And so I want two numbers to multiply to be 12. I want them to subtract to be the 4 in the middle because this tells me my signs will be different. And just like we said before, that's going to be your positive 6z minus 2z. And once again, with the box method, what happens is we just handle those terms a little differently and put them inside that box. So that my 4z squared goes up in the upper left, bigger term goes up here in the upper right, negative 2z goes in the lower left, and a negative 3 in the lower right corner, I'm sorry. Now I'm going to factor across this row, and I'm going to factor out a 2z. Across this row, I'm going to factor out a negative 1. Up this column, I'm going to factor out a 2z, and up this row, I'm going to factor out a positive 3. So that I end up with a 2z minus 1 and a 2z plus 3. Keeping in mind that if I circle that as my answer, that only gets me back to here, but my original problem had that 20z factored out. So I need to keep it in there. And then finally that slide, divide, and reduce. With slide, divide, and reduce, the name tells you what to do. And just like we said before, that all it does, honestly, is take this piece and factor it out. So my 4z squared plus 4z minus 3, I'm going to slide it by multiplication. That'll give me a z squared plus 4z minus 12. That factors very easily because the front coefficient's 1 as a z and a z. Different signs because this sign here, two numbers that will multiply for 12, subtract to be a 4 will be a 6 and a 2. 6 here, 2 here. Now I'm going to take that 4 that I multiplied out and I'm going to divide it back in. 6 divided by 4 and 2 divided by 4. There's the division. And remember, it's slide, divide, and reduce. I need to reduce this fraction to 3/2 and reduce this fraction to 1/2. And now just clear out the fractions. I don't have fractions in my answers, so I'm going to clear it out by multiplying everything by 2. And the same thing here, multiply everything by 2. And so be careful about circling that as your answer, as I just about did, because remember, this will only give me to here, but I need that 20z so that I can get all the way back to the beginning. So that's what happens whenever you can divide out a common monomial before you get started. Let's try just a couple more examples of this, especially if you have extra variables in there. Does that cause problems? No, not at all. So let's take a look at a 12a squared b minus 34ab squared plus a 14b to the third. So what happens with this one is, notice that I can divide out of each coefficient, a 12, a 34, and a 14, I can divide a 2 out of each one of those. And here I can divide b's out of each one of those. Now, these two have a's, but that one doesn't, so I cannot divide any a's out. So divide this by 2b, and I'm left with a 6a squared. Divide this by 2b, I'm left with a negative 17ab. And divide this by 2b, and I'm left with a 7b squared. There's nothing more common that I can divide out, so now I'm headed for any of those four methods with my guess and check, factoring by grouping, box method, slide, divide, and reduce. Notice here that guess and check's not too terribly bad because there's only a way to split up a 7b squared. It's a 7b and a b. This tells me same signs. This tells me both minuses. 6a squared there will split up as a 6 and a 1 or a 2 and a 3. So just try out the 6 and the 1. If it doesn't work, change it up. Outside I get a negative 6ab. Inside a negative 7ab. Those combine to be a negative 13ab. Not what I wanted a negative 7. So switch it out. Call this the 6a. Call this the 1a. That gives me a negative ab right there and a negative 42ab here. Well, that doesn't combine to be a negative 16 because that's a negative 43. Definitely not right. So toss the 6 and the 1, try the 2 and the 3. Out here I get a negative 2ab and here a negative 21ab. Those combine to be a negative 23ab. Nope. So switch it up. 3 here, 2 here. Keeping in mind, only switch one set of slots. Don't switch both slots. It'll take you back to where you were. So out here I get a negative 3ab and here a negative 14ab. Sure enough, there's my negative 17ab that I wanted. And so I know that this is the correct factored form. And I can FOIL this, gets me back to here, distribute the 2b through, gets me back to the beginning so I know I'm right. And like we said before, if that guess and check is a little bit too cumbersome, then you can certainly take right here and you can do it by any of those other three methods like factoring by grouping. So what will happen here is my 6a squared minus 17ab plus 7b squared. I'll multiply the 6 and the 7 to get a 42. So I want two numbers that will multiply for 42. Notice this tells me same sign, so they're going to add to be this middle number of 17. And that is definitely going to be a, sorry, blanked out there for a second. It's going to be a 14 and a 3. So this will split up as a negative 14ab and a negative 3ab. And so now I can group up my terms. I'll group these two, and I'll group these two. Here, what's common? That's going to be a 2a. When I divide it out, I get a 3a minus 7b. And here, all I can divide out of there is going to be a b. And notice that because I want this to be a positive 3b, because I want these parentheses to be identical, that means I'm going to divide out a negative a out of both. I'm sorry, negative b. Whew, getting kind of tired now, I'm sorry. There we go. I want it to be a 3a, so I'm going to divide a negative b out of there. Divide a negative b out of here, I'm left with 3a. Divide a negative b out of here, I'm left with a negative 7b. And so you can see that I have, again, very weird looking terms, but within this box and within this box, they both have that 3a minus 7b. Write down what's left, 2a minus b, and I'm going to keep that 2b that I divided out from the beginning. And you can see that what's circled in red is the same thing as what's circled in blue. And like we said before, the box method starts off the same way in the sense that I'm going to take my 6a squared minus my 17ab plus my 7b squared. I'm going to multiply 6 times 7 to get that 42. So I want two numbers that will multiply for 42. They are going to add to be that negative 17. And just like we said before, that's going to be the negative 14ab and the negative 3ab. But now I'm going to handle those terms differently. I'll put them within the box. So that my 6a squared goes in the upper left, my 7b squared goes in the lower right, bigger one up here in the upper right box, Smaller one down here in the lower left box. Now I'm going to factor across the rows, factor along the columns. So across this row, I can divide out a 3A, sorry, no, a 2A, my apologies. Across here, I can divide out a B. Here, I can divide out a 3A, and here I can divide out a 7B. Keeping in mind that within these parentheses, I do want to have same signs, both minuses. That tells me divide out a negative B, 7B and a negative B. So I get a 2A minus B and a 3A minus a 7B. Keeping in mind that I got to keep that 2, oh, good grief, this should be a 2A. I'm sorry, this should be a 2B. My apologies. 2A here, there, and the 2B out there. I'm sorry. So keep that 2B out there. And you can see that the 2B, 2A minus B, 3A minus 7B. Granted, the parentheses are a different order, but it's the same stuff. And finally, that slide, divide, and reduce. And again, the slide, divide, and reduce, what it's only going to do is take care of what's back here. Slide it out by multiplication. So that gives me a squared minus 17ab plus a 42b squared. This is easily factored because I have a coefficient of 1, splits up as an a and an a. Same signs, both minus. Two numbers that will multiply for 42 and add up to be a 17 are going to be my 14 and my 3. 14b, 3b. Now I'm going to divide the 6 back in because I don't want to keep it out. And I'm going to reverse what I did to get it out, and that was multiplication. So I'm going to reverse that with division. So there's the divide. And now a very important step of reducing. 14/6 reduces to 7/3. And 3/6 reduces to 1/2. And now all I'm going to do is clear out those fractions. Multiply everything in here by a 3. And multiply everything in here by a 2. And remember, I've got to keep that 2b out front so that I can get all the way back to the beginning. And you can see, once again, very same answer in both cases. All right, last example. So remember, you always start with, is there something common to each and every term that you can divide out? And there certainly is in this case. I can divide a 2 and a y out of every single term. When I do, I'm left with a 3x squared. Here I'm left with an x, negative x, and here I'm left with a negative 30. So that at this point, I'm going to try to split this up. The old guess and check will allow me to set up a double parentheses, and I'll split this up as different signs. One's a plus, one's a minus. This splits up as a 3x and an x. But with that 30, there's lots of options. I've got a 30 and a 1. I've got a 15 and a 2. I've got a 6 and a 5. Lots of choices there, but I want two numbers that will multiply for 30. Well, I can't do that because I've got the 3 out front here. So I just have to take a stab at it and see what happens. Try the 30 and the 1. Outside I get a negative 3x, inside a 30x. That's not working. Switch them up. Call this the 1, call this the 30. Again, just switch one set of slots, not both. Outside I get a negative 90. Inside I get a positive 1. That's certainly not going to work. So toss the 30 and the 1. Try the 15 and the 2. Outside I'm going to get a negative 6x. Inside I'm going to get a positive 15x. Those combine to be a 9x. That's not right. Remember, if it's the right number, wrong sign, just switch signs. But that's not even the right number, so I have to switch the numbers. Now I get a negative 45x and a positive 2x. That's certainly not going to work because that's a negative 43x. So toss that out and try the 6 and the 5. On the outside, I get a negative 15x. Inside, I get a positive 2x. There's a negative 9x. Still not right. Switch it up. Make this the 5 and make this the 6. Now on the outside, I get a negative 18x. And inside, I get a positive 5x. There's a negative 13x. I believe I missed something with the 15 and the 2. So let's go back and try the 15 and the 2 again. Out here, I get a negative 6x. Inside, I get a 15x. And that won't work because that gives me a 9x. Switch it up and call this the 2 and this the 15, and that doesn't work either. Oh, and I forgot another option of 3 and 10. My deepest apologies. Last option is 3 and 10. So try the 3 here, try the 10 here. That gives me a negative 30x and a positive 3x. That doesn't work because that's a negative 27x. And switch it up and call this the 10 and this the 3. Now we get a negative 9x and a positive 10x. There's the positive, but it is a positive 1x. I got the right number, wrong sign. Easy to fix. Switch that up. There's the right combination. So here's a clear-cut case where maybe one of those other methods would be a little bit better, the factoring by grouping, the box, or the slide, divide, and reduce. So let's see what happens with that factoring by grouping, because you can see that when you've got a lot of options here, sometimes it can be a bit cumbersome. So try that factoring by grouping. So what happens here is I'm going to take just what's right here, 3x squared minus x minus 30. I'm going to multiply it to the back. So 3 times 30 will give me 90. I want two numbers that will multiply to be 90. And those same two numbers are going to subtract to be a 1. Because they're going to subtract because this tells me I'm going to have different signs in the end. Those two numbers are going to be a 10 and a 9. So this is going to split up as a negative 10x and a positive 9x. Because 10 times 9 will give me 90, and negative 10 plus 9 will give me a negative 1. They're going to subtract to be that negative 1. So now I'm going to group them up. I'm going to group these two, and I'm going to group these two. Now within these two, what's common that I can divide out? Just an x. And I'm left with a 3x minus 10. Here, what's common? I can divide a 3 out of each. And I'm left with a 3x and a minus 10. And just like we've said many, many times, now I've got some very odd-looking boxes, but within each box, I have a common 3x minus 10. So I'm going to divide that 3x minus 10 out. And when I divide it out of here, I'm left with an x. Divide it out of here, I'm left with a 3. But don't forget that common 2y that I divided out from the very beginning, so that when I FOIL this and get back to here, when I distribute the 2y through, I'll get back to the very beginning. And like I said many, many times, these are going to be the same thing. So with that box method, starts off the same way with this 3x squared minus x minus 30. Multiply it here to get the 90. That tells me I want two numbers that multiply for 90. They're going to subtract to be that negative 1. And like we said before, that's going to be my negative 10x and my positive 9x. But now I'm going to put those within a box. So in order to put them within the box, here's my 3x squared, here's that negative 30 in the back, negative 10x goes in the upper corner, 9x in the lower corner. And now I'm just going to factor across each row, and I'm going to factor along each column. Out of here I can take an x, out of here I can take a 3, out of here I can take a 3x, and out of here I can take a 10. Keeping in mind that this tells me my signs are going to be different. Notice that both of these have a common negative, so I'll take the negative out of that one, giving me an x plus 3 and a 3x minus 10. And once again, keep that 2y out front so that I can multiply and get all the way back to the beginning. So there, I've got the very same answer. And finally, slide, divide, and reduce. color so it doesn't blend up there. Slide, divide, and reduce. The words tell me what to do. So I'm factoring my 3x squared minus x minus 30. I'm going to slide it out by multiplication. And when I do, I get x squared minus x minus 30. That's easily factored into, this tells me different signs. Front slots are x and x. Two numbers that will multiply for 30, and they're going to subtract to be a 1 because the signs are different. And that's going to be my, it's going to be a 6 and a 5. This will be my 5, this will be my 6, because out here I get a negative 6x, and here I get a positive 5x. So, oh, I apologize. 3 times 30 will give me a 90. There we go. Now, the two numbers that will multiply for 90 and subtract for 1. There's the 10 and the 9 that I was looking for. Okay, so outside I get a negative 10x, inside I get a positive 9x. I forgot that when I multiplied that 3 times 30, it should be a 90. So now I'm going to divide that 3 back in because I don't want to lose it. There's the divide. And now I need to all-important reducing so that I make sure everything clears out properly. 9 divided by 3 is 3. There's the reduce. And now I'm just going to clear out those fractions. This doesn't need to clear out. It's great shape. This one does. Multiply everything by a 3. And then, like we said before, retain that 2y so that when I FOIL all of this out, I can get all the way back to the beginning. And sure enough, when you FOIL this, you'll get to here, distribute your 2y, you'll get to there, and you'll know that it's right. So, these are the 4 methods for factoring your trinomials when the leading coefficient's not a 1. Just remember, always, always, always look first to see if there's something common that you can divide out before you do anything else. Once you've done that, you can take what's left within that parentheses and you can see if you can factor it any further. But that's how it's done. And I'll see you next time.